So there's a lot of new terminology that goes along with building a microservices infrastructure around containers. And the next several slides are actually going to go through those so that we have a good understanding of what we're working with and so that we're speaking a common language when it comes to containers and the architecture and world around them. The first thing that we're going to look at is called a container itself. A container is an application packaged with its dependencies. Okay? Now, in the next several slides, we're going to dive deeper into these components. So let's just go through them relatively quickly. So a container engine is the system that allows us to build those containers and manage the containers themselves. The most popular container engine is called Docker. You may have heard that term. Okay? So that's a container engine, one that you might choose to use or your developers might choose to use as they're creating those containers and shipping them over to you. Then we have a container host. A container host is typically a Linux operating system. I say typically because there are examples where we can run this on Windows as well, more recently. But a container host is a virtual or physical machine, we like virtual machines, right? That allows us to provide the underlying operating system for the containers themselves so that they can actually run in the environments that you're looking for. And then finally, we have Kubernetes. Okay? Now, Kubernetes is an orchestration tool developed by Google to help us operationalize all of these containers and put them into production. So what's a container? So imagine I'm a developer and I'm building a Java application. And I'm going to choose a particular version of Java and I'm going to build that application. And I need all of the runtime libraries required to run that Java application. So I take that application, I ship it into operations, and I say, hey, put this new version of my Java application into play. And what if they've got the wrong version of the runtime libraries? Will your application run? Well, maybe, but I can't be sure. Will it run properly? Will there be any issues? Well, maybe, but I can't be sure. So I need to package, as a developer, my application along with the particular runtime libraries that are required for that application. That's where a container comes into play. I have my application, and I have everything that that application requires in the container. I can then, just like a shipping container, move it from my massive shipping boat onto a train, onto a truck. I can move it from testing into staging into production with a container that can run and fit anywhere. Okay? So the container itself contains the application that I've built or that the developer has built along with all of the dependencies for that application. Now I can just ship that off and now it's going to run on whatever system they choose to place it on. Containers have really taken off in popularity. If you look at this interesting little chart here, you can see in the last 5 or 6 years here where the numbers of virtual machines that are kind of out there have remained relatively flat, okay? But in terms of containers, we can see an exponential growth in the use of containers. Now, is this a realistic operation? Is this a realistic picture? Well, I'm not sure, because we know that in our virtual machines, most of our applications are monolithic, but that when it comes to containers, we're running microservices. So if it takes to run a particular application 4 or 5 or 6 little microservices, there's going to be a significant number of containers for every virtual machine that we would have traditionally had. But you can certainly see that there is significant growth in the use of containers. And so as a vSphere administrator, I really want to know about this stuff because I know that if I haven't been asked about it already, I'm certainly going to be asked about it soon enough and probably be asked to place these things in operation in my environments that I'm responsible for. So what's a container host? Well, you're going to start with a virtual machine with an operating system installed, like Ubuntu, okay? And then I'm going to install a container engine, like Docker, in that container, in that, say, for example, Ubuntu operating system, okay? So now I have the operating system that has the ability to interact with physical hardware. I've got the Docker engine, or the container engine, that allows me to run my containers, and everything's ready to go. So the container hosts are the operating systems in virtual machines that will be running multiple containers in each of these. Now, like it says here, container hosts come in a couple of different forms, okay? They can come from a standard Linux virtual machine, but they can also come from OSs that are specifically built just to handle containers. Think of a really stripped down Linux operating system where I don't need a GUI, it's just a command line interface, and it's got only the tools that I need to help me manage containers, okay? Photon OS from VMware is a distribution like that. Fedora CoOS from the Red Hat folks is an example of an OS specifically developed with containers in mind. And of course, we can run those operating systems both bare metal on physical machines, but we know some of the issues around that virtual machines have now solved. So running, in our opinion, in my opinion, virtual machines are a much better way to sort of manage all of this stuff. Now, what happens when a container is actually placed in operation? What happens at runtime? Okay, so the containers themselves can run on any container host that has the same operating system kernel, okay, that is specified by the container. So if I'm doing Linux, I need to, at the very least, be on the same version of the Linux kernel. I'm going to access that container with its fully qualified domain name or IP address. So the containers themselves get networking, okay? They get IP addresses. They get a virtual NIC that is then plugged into a virtual switch. We're going to be talking lots more about that in module number 5 coming up really, really soon, okay? So in a Linux-based container host, I may have lots of IP addresses and lots of fully qualified domain names registered in DNS with those IP addresses. Now, the container itself is isolated from other containers, okay? So it can only access the resources that it has within that container itself. I can log into a container and work within that container with tools like SSH, okay? And I will, when I'm working within that container, see no presence of the other containers that are there. In that way, if a container becomes compromised, just like a virtual machine, it is now isolated in its own environment and doesn't have the ability to affect the other containers that might be running on that container host. So the container engine is the control plane, or the control mechanism that allows me to manage all of the containers on a particular container host, okay? Container engine like Docker is one of the examples that we mentioned before, okay? And the container engine does a number of different things, okay? It allows me, first of all, I'm going to build the container itself. Now, there's usually a plain text file, like in the example of Docker, it's called Dockerfile. A Dockerfile is a text file that describes the commands that are required to build the container. Maybe I'll start with an empty container and I'll install a Java runtime library, or I will install a web server into that container, and then I'm going to copy a bunch of files. So it'll contain all of those commands that are required to then build that container, okay? So I use that along with a command like Docker, right, to build the container itself, okay? Now, I can then commit that container to an image and take that image and push it into a repository. A repository is a storage area for my containers, from which I can pull existing containers onto container hosts and operationalize them. Okay? The most popular repository that we have for containers is called Harbor. Okay? The container engine also allows me to stop containers, remove containers, suspend and restart, and it'll also tell me the status of running containers on a particular container host. So what now then is the difference really between a virtual machine and a container, especially as it applies to the vSphere administrator? Okay. Now we know that containers and virtual machines both allow us to run particular applications, and that when we're dealing with microservices sorts of things, we like to use containers because it gives us a huge amount of flexibility. But from the perspective of vSphere, the infrastructure that's underlying the entire thing, starting from the bottom with the physical infrastructure, then installing ESXi, then building a virtual machine, it's all the same. Notice here in our virtual machine infrastructure, where we'll install a VM, be it Linux or Windows or whatever virtual machine we need, right? We'll build that VM, we'll install the guest OS, we'll install the dependencies for a particular application, okay? Maybe I need to install on Windows a Java runtime library, okay? And then I'll install the applications. All of those applications that are running there will then rely on the dependencies that you've installed. And in many cases, two versions of the same set of libraries can conflict with one another. Okay? Now, we'll start at the same place when it comes to a container infrastructure, where we have a virtual machine running a guest OS, but this system will now be called the container host. Okay? That container host will have the container engine, once again, like Docker is an example of that, and then we'll include the containers themselves, the applications, and the dependencies for that application. So now as I run multiple applications, I can have multiple sets of dependencies for each of those applications, isolated from one another within a container. They work in different ways, but you might think of them similarly, because as virtual machines are isolated from one another, containers within a virtual machine are also isolated from one another. Okay? Now, in a virtual machine, we have the entire guest OS. Okay? But in a container, we are only including the application's dependencies. We have to have an underlying operating system. Okay? And that underlying operating system in the container world gives me access to the resources that are running on that container host. Now, if that container host is a virtual machine, right, then those resources will then be managed by the hypervisor itself. Okay? So if you think about it like this, virtual machines are scheduled by the hypervisor and run on the hypervisor. Containers are scheduled by the container host. They run on the container host, which then are scheduled by the hypervisor and run on the hypervisor. So it's a new layer almost of, I would call it virtualization, but I think rather I'll call it isolation or containerization. Okay. How long does it take to start a virtual machine? Well, virtual machines require a boot process, right? We boot the BIOS of the VM, we then start up the entire guest OS, and then we can launch the application. But when it comes to containers, the container host will say has already been booted. So all we have to do is start the container itself in just a matter of a second or two, and the container is up and running. So for us to start many hundreds of containers on a few sets of container hosts that are already booted is obviously much faster than starting several hundred virtual machines from cold boot and going from the beginning there.